Welcome to Do the Math America, where we appreciate mathematical precision of all forms. Okay, back to work on fractions and decimals from page 63 and 64 of the Beginning Algebra book. Please check the description box below this video for a PDF file of the textbook. Fractions and decimals. To change a fraction to a decimal, we divide the numerator by the denominator. For the fraction 1/2, we divide the numerator 1 by the denominator 2. To divide a larger number into a smaller number, we need to convert the dividend into a decimal. So here, 1 becomes 1.0 divided by 2. If you are uncertain how to divide decimals, please watch my earlier video, Lesson 18, on dividing decimals. So 1 divided by 2 equals 5/10. It's always a good idea to write a 0 in front of the decimal point, just to be clear when the decimal starts. To convert the fraction 1/3 to a decimal, we take the numerator 1 divided by 3, the denominator. So 1.0 divided by 3 equals 0.3. That continues to repeat, so it will be 0.3333, etc. So this is a good example of seeing how repeating decimals occur. And we write the decimal as 0.3 with a repeating bar over the repeating digit, in this case 3. -1/8, we take the numerator 1 and divide it by the denominator 8. We draw parentheses around the equation with a negative sign in front to make sure we remember to include the negative sign when we finish our calculation for the decimal. And we end up with the decimal 125 thousandths, and we write it out as -0.125. For the fraction 3/4, we take the numerator 3 and divide it by the denominator 4. We add a decimal behind the number 3 and add zeros behind that so that we can divide 4 into 300. And we get 75 hundredths. 5/12 converted into a decimal is 5 divided by 12. And once again, we make 5 into a decimal, adding as many zeros behind the decimal in order to complete the problem. And we find out here, once again, we end up with a repeating decimal. So it's 0.416 with a repeating 6. So we write out the decimal as 0.416 with a repeating bar over the 6. To box your answer so you can see what the final calculation is. We convert the fraction 3/11 to a decimal by calculating 3 divided by 11. And right away we start by making 3 into a decimal, adding as many zeros as necessary to complete the calculation. We see that there is, once again, repeating decimals. In this case, the repeating decimals are 0.2727. So we write the decimal as 0.27 with a bar over both digits 2 and 7. To change a decimal to a fraction, rewrite the decimal as a fraction whose denominator is a power of 10, then write the fraction in simplest form. So 5/10 becomes 5/10. To convert to simplest form, we do prime factorization of both the numerator and the denominator and cancel out the like factors. So the numerator 5 is a prime factor, and the denominator 10 has two factors, 2 times 5, and now we just cancel out the common factor 5 for both the numerator and the denominator, leaving 1 in the numerator and 2 in the denominator, or 1/2. To convert 25 hundredths into a fraction, we write out 25 100ths. Then we find the prime factors of both 25 and of 100. And here I use shortcut division, which I demonstrated in lesson 22, Prime Factorization, shortcut division. 25 factors out into 5 times 5, and 100 factors out to be 2 times 2 times 5 times 5. And then we simply cross out the common factors, the 5's in the numerator with the 5's in the denominator. And we end up with 1 in the numerator and 2 times 2, or 4, in the denominator, or 1/4. For the decimal negative 125 thousandths, we need to make note of it's a negative number, so we need to keep track of that negative sign. And here it's a good idea to use parentheses to highlight that you do have a negative sign to include at the end of the problem. And then you write out the fraction 125 over 1,000. Next, we do the prime factorization of 125 and the prime factorization of 1,000. Once we break down the numerator and the denominator by their prime factors, we can then cancel out all their common factors. And of course, what remains is the fraction in its simplest form. So 125, the numerator breaks down to 5 times 5 times 5. And 1,000, the denominator, breaks down to 2 times 2 times 2 times 5 times 5 times 5. And we write those factors out corresponding to the numerator and denominator accordingly. And we are now ready to cancel out like factors. So the 3 5's in the numerator cancel out with the 3 5's in the denominator, and what remains is a 1 in the numerator and 2 times 2 times 2, or 8, in the denominator. And if you notice, I've been keeping track scrupulously of the negative sign using the parentheses. So negative 125 thousandths simplifies to the fraction negative 1/8. To write the decimal 3.75 into a fraction, we keep the whole number 3 and write 75 100ths for the fraction. And next we simplify 75 100ths into a fraction in its simplest form by breaking down the prime factors of 75, the numerator, and the prime factors of 100. Here I'll just draw a red box over 75 100ths so you can see that I'm working on simplifying that part of the fraction. So now I'll just break down 75 100ths into their corresponding prime factors. 75 breaks down to 3 times 5 times 5, and 100 breaks down to 2 times 2 times 5 times 5. And we line up those factors in the denominator, and once we do, we can cancel out like factors. So the 2 5's in the numerator cancel with the 2 5's in the denominator, leaving a 3 in the numerator and 2 times 2 in the denominator, or 4. 75 100 simplifies to 3/4. So 3.75 is 3 3/4. To change a repeating decimal to a fraction, for each repeating digit, write the denominator with a number of 9 and 0 for each non-repeating digit. Subtract the non-repeating digits from the numerator. 0.1 with a repeating 1 becomes 1/9. 0.2 with a repeating 2 becomes 2/9. 0.3 with a repeating 3 becomes 3/9, which simplifies to 1/3. 0.9 with a repeating 9 becomes 9/9, or 9/9, which equals 1. For the repeating decimal, 0.27 with the 27 in repeat, we write the fraction as 27/99. So 1/9 for each repeating digit. And then we simplify by prime factorizing both the numerator and the denominator. So the prime factors of 27 are 3 times 3 times 3, and for 99, they are 3 times 3 times 11. Now we can cancel the common factors of the numerator and the denominator, and we end up with the fraction 3/11. The repeating decimal, 0.123, in which 1, 2, 3 are repeating, we write the fraction as 123/999, so a number of 9 for each repeating digit. Next, we do the prime factorization for both the numerator and the denominator. So I use the shortcut division to find that 123 breaks down to 3 times 41, and 999 breaks down to 3 times 3 times 3 times 37. And I write those factors to match up with the numerator and denominator, and then now I can eliminate common factors. The 3 in the numerator will cancel with the 3 in the denominator, leaving 41 in the numerator, and 3 times 3 times 37, which is 333 in the denominator. The decimal 0.1234, in which all 4 digits are repeating, becomes 1,234 over 9,999, 1/9 per each repeating digit. And here is a good opportunity to start playing with the numbers a little bit to find out, well, does 1,234 and 9,999, those are very big numbers, do they have common factors? And so we see that 1,234 is an even number, and it breaks out to 2 and 617. Now I pause in my shortcut division at this point because 617 might be a prime number. But I check to see if 7 is a factor of 617 just in case, and I can see that no, it is not. So I will pause there and move on to 9,999 and see what the factors are of that number. Okay, so now I have 3 times 3 times 1,111. So I need to compare 617 and 1,111 to see if there are some hidden prime factors that are common to both those numbers. And at this point, it is a bit of a guess and check. I'm just decided I'll try 37 and see if that is a factor of 617, matching up the last digit 7 to see if it will go into 247, and I see, okay, there's no multiples of 7 that end in 7 that would work here. And I try various other prime factors like 43, and that doesn't work. And I play with a few other prime factors just to see if any of those might work. And eventually I am satisfied that there are no hidden prime factors that are common to 617 and 1111. This process of hunting for prime factors and their multiples is not a waste of time for you because you will gain numeracy or a good understanding of how numbers work by doing these as practice problems. This is actually the secret of getting good at math. People who are good at math take the time to crash around with the numbers so that they can get to the right answers. For the decimal 0.01, in which 1 is the repeating digit, we write 1 over 9 for the repeating digit and 0 behind the 9 for the non-repeating digit. So 0.01 with a repeating 1 is 1 over 90. Now let's look at 0.46, in which 6 is the repeating digit. So for the fraction, we start by writing 46 in the numerator, and then we need to subtract 4 from the numerator because it is the non-repeating digit. So the numerator is 46 minus 4, and the denominator has a 9 for the one repeating digit of 6 and a 0 for the non-repeating digit of 4. So it's 90 in the denominator. The fraction is 42 over 90, which we can simplify because those are both even numbers. So we do a prime factorization of 42, and we get 2 times 3 times 7. And then we do the prime factorization of 90, which gives us 2 times 3 times 3 times 5. And then we eliminate like factors in the numerator and the denominator. So the 2's cancel, and then the 3 in the numerator cancels with one of the 3's in the denominator, and that leaves us 7 in the numerator and 3 times 5, or 15 in the denominator. So 0.46 with a repeating 6 becomes the fraction 7/15. Okay, let's look at 0.1234 with 3 and 4 as the repeating digits. And we note that 1 and 2 are the non-repeating digits that need to be subtracted from the numerator. So we start by writing the numerator as 1, 2, 3, 4 minus 12. And since we have 2 repeating digits, 3 and 4, we will have 2 9's in the denominator, followed by 2 zeros for the 2 non-repeating digits, 1 and 2. So the denominator will be 9900. So the fraction starts as 1222 over 9900. Okay, now I do shortcut division to find all the prime factors of each of those numbers. And I start with 1,222, and I get 2 times 611, and I will pause there for now before going on the mad hunt for additional prime factors. I move to 9,900 and see what are the prime factors that make up that number. And I see that 9,900 breaks down nicely into a bunch of 2's, 3's, and 5's, and an 11. And since 611 is not an even number, it is not divisible by 2, it does not end in 0 or 5, so it is not divisible by 5, and the digits add up to 8, which is not a multiple of 3. So therefore, I only need to check if 611 is divisible by 11, and it is not. So I can be assured that the simplest form of the fraction is 611 over 4,950. And now for the most important part of this math lesson, which are the practice problems that you can do to develop your skills. You can pause this video here and take a screenshot of these practice problems, print them out so you can work on them, or you could go to the description box below this video for the link to the PDF file of this textbook and print out those pages from there. In any case, please take the time to do as many problems as you need to gain confidence in the skill converting fractions to decimals and vice versa. And as always, please check your answers with the answers in the back of the book to make sure you did the problems correctly. If you find my video helpful, please give me a thumbs up. Subscribe to my channel for more lessons on math, and please share this channel with anyone you know who wants to learn math. Thank you for joining me at Do the Math America.